probably the most boring part of the presentation, and I appreciate that, because the building inspectors and the building plans reviewers are very familiar with these fire resistance concepts and apply them throughout their reviews on a regular basis. Unfortunately, when it comes to fire rated duct systems, it usually falls on the shoulders of the mechanical plans reviewers and inspectors. And then that takes a fundamental understanding of these fire resistance concepts so that we can apply them to our review of the designs and the products that we're going to be responsible for when it comes to the fact that it is a duct that is now acting as a fire rated assembly. And your classical training will have failed you in this regard, because it's so much more than understanding the SMACNA fabrication standards. It's so much more than understanding the SMACNA hanging requirements. There are, it is akin to the difference between a cold or hot water plumbing system versus a sprinkler system. The regulatory oversight required to make sure that life safety water delivery has all of the qualities that it needs to, and the reliability and its robustness to survive the fire imparts a tremendous amount of additional effort in the review and inspection of those plumbing systems to get to their life safety qualities. And it is unfortunately just as difficult and nuanced as that when it comes to fire rated duct systems, where it's not going to just be another duct system, another HVAC system. It is a whole extra level of effort that needs to go into this if we're going to get it right. And I can't say that I know why the industry has, conventionally treated it that way. But I think that's part of the problem. The conventional wisdom has been, you just put it in like another duct system. The contractors, don't take any special care. The sheet metal contractor delivers his product to the mechanical contractor without ever having seen the fire rated assembly design that the product manufacturer of what's the skin that's going to go on that ductwork needs to have a conforming assembly. How can he possibly? This is why I say you can't do it after the fact. If the construction requirements require bolted flanges and special gaskets and locking Pittsburgh seams and external reinforcement every so many feet, because it's a large duct. If he hasn't seen the design and fabrication requirements for that product assembly, how can the sheet metal possibly be right when it lands on the site? And then the insulation contractor, after it's up, is simply told, go wrap that. And so he goes and he wraps it. Is he looking for the underlying conformance for his product's assembly? Is he even looking at the assembly himself? I posit to you that if he's not taking care on properly banding his collared seams, if he's not pinning the bottom of ducts over 2 feet wide, if he's putting adhesive tape and walking away from a plenum box that's over 5 feet wide, if he's using strap to hold up a 5-foot plenum box, I'm pretty darn sure that I don't need to peel the onion back when I walk in and see that. That's why I say you can see the stuff from the floor. I can look at a duct and look down the length of that duct. If I don't see that bump at every duct joint where that bolted flange needs to be, I'm pretty confident I don't have bolted flanges. If I don't have bolted flanges that I can see through the wrapping, I probably don't have the locking Pittsburgh seam. I probably don't have the internal-external reinforcement as it gets larger and larger. I can peel the onion back to do a thorough inspection, but from the floor, I can tell you in most instances that we don't have a compliant assembly, and it's not okay. It's not holding your fingers. In fact, it's worse than doing nothing at all. I'm asking you to go back and challenge what has always been okay, what we've always been told by many of these product manufacturers who have not properly tested their products, that this is okay. Because I want you to think about this. If we take a wall that was tested to 10 feet and we actually build it 20 feet, is that okay? If you're familiar, if you talk to your building inspector counterparts, you realize that they can go to 20 feet, but because it was bigger than what was taller than what was tested in the furnace, they have to make accommodations. They have to address the higher bending moment. So they're going to use deeper studs, heavier gauge studs, maybe closer spacing for those studs to get to the 20-foot limiting height instead of the 10-foot limiting height. Okay. When we have duct systems that go bigger than the limit on the listing card, it's the same thing, right? So we have to know what the duct size limit for that assembly is on the listing card. If the size limit is different for the duct A test than it is for the duct B limit, and we're required to use the lower of the two results, and duct B is the lower of the two results, which it always will be because it's the weaker side fire exposure, is it okay to use the larger duct size from duct A? And the answer is no. If we're going to use the duct B configuration, we use the limiting variables and parameters of the duct B design. So if it's a smaller duct size, that's as big as we go before we have to start asking more questions. And when we have duct work that is flimsier, does not have the locking seams to hold it together as it gets hot and starts bending and twisting as those temperature effects cause uneven thermal expansion of the ductwork, it's going to come apart. And not only is it going to come apart, it's going to come apart faster than if we had done nothing at all. Because if you've ever held many of these fire-rated insulation products in your hands, it's not thermal insulation. It's really, really heavy. When you put 2 layers on there, as is minimally required for every product manufacturer in this class, it takes no less than 2 layers to get to our duct B. At the penetrations of the walls and floors, it's supposed to be a 4-layer collar to get to that 2 hours. So now I need to have room for 2 layers of insulation on the ductwork. I need to have room for 4 layers at the penetrations of the floor, ceiling, and wall assemblies. And all of that is weight, and it's a lot of weight. And if the hanging system is inferior, if we're using 8-foot, 10-foot spans, if we don't have the bolted joints, it's just going to be more weight on something that already wasn't enough in the first place. It's just simply going to cause the load to be higher and accelerate how quickly at temperature it fails. So we need to change the paradigm. We need to shift the point of examination to much earlier in the process, because we need to be looking at the duct very carefully before the wrapping paper goes on, or we're going to miss crucial elements of the minimum requirements for that assembly to be the hourly rating that we want. And if you don't ask for the listing card, you're not going to get all those details because they're not on those glossy 2-page product data sheets. None of that information is in there. The only place you're going to get that is from the actual product approval card, which you can get yourself from. You can look at the product data sheets and get the design number and go to UL and go to Intertech and go to their online fire resistance directories and download these product approval cards with all the details you actually need to make sure it is actually 2-hour rated for the orientation that you want. And that means you need to follow that configuration, not some other configuration that the duct has been tested for, or even worse yet, in some manufacturers' cases, they'll claim they have an E119 design approval, and it's only been tested E119 as their grease duct assembly. Does that convey to anything other than their grease duct? No. That means they can go through a 2-hour fire barrier shaft wall with their zero clearance material only for their grease duct. That means 18 gauge welded stainless or 16 gauge welded black steel. It doesn't mean they can use any SMACNA construction or SMACNA joining method underneath. It means they need to follow their grease duct design, and then it's only good for a type 1 commercial kitchen exhaust. You can't use those designs for ventilation tests. And the reason is, we're going to talk about, I'm asking you to challenge the conventional wisdom that may have led us to the place that we are, and the way that we get to replacing that rule of thumb that ran astray, who knows how long ago, for whatever reasons, we have the ability to ask the right questions, and that gets us to a place where we can change the situation. And the changing the situation, I mean a paradigm shift that gets us to actually providing the fire resistance that's expected from fire-rated duct products when we apply them. And that is going to start with asking for the listing card. We don't get that information from the product data sheets. There's one or two glossy slicks. They may have 7 or 8 listings. If you read them closely, they may identify all of the different product approvals and configurations that product may come in. But until you get the actual product listing card from the UL directory or the Intertech laboratory directory, you don't actually know which ones are good for what purposes and what they actually passed. And if you recall, we're allowed to use each configuration for what it was tested for. So we don't get to use grease duct assemblies for ventilation purposes any more than we can use ventilation duct for grease duct. We don't get to use horizontally tested assemblies for vertical applications unless it was tested vertically, and vice versa. So all of those all of the meat that we need to validate that the correct product configuration is being applied in the first place, and all of the meat that we need to inspect it to confirm that the assembly is conforming with that design and therefore actually fire rated, is going to be on the listing cards. We can ask for those, hopefully get those. If they don't give that to you, you can get the design numbers off the product data sheets, and they can be used to go to here we're looking at the UL product IQ. We can search the online fire resistance database for any configuration that is on the UL directory. We can jump and scan through the available, like I said, it's slightly less than 40 designs in the ventilation duct fire rating category, HNLN and HNLJ. Fire rated grease duct assemblies are in a separate category. They're not the same. They're not interchangeable. That's why they're aggregated in 2 different groups, different categories of testing, different test standards. And one of the things that we'll find is that Intertech Laboratory has slightly different search terms, or different search input, but they have all the same information that you can search for: the company name, the listing category, or the actual product ID, and or the listing number. And we're going to see here that you're going to need to ask questions. These are the questions you need to ask. If you're not asking these questions, you're not going to get the right information you need to make an educated decision. So we're going to see that it's actually a pretty long list here that we need to check, because we need to make sure that they're using the correct configuration that conforms with the prescriptive fire resistance expectations from the code. But we also need to make sure that all of the little things that go into making it right are things that we are actually checking along the way, because it's not going to be minimum SMACNA, right? It's going to be SMACNA on steroids. So we need to recognize immediately that the prescriptive test standard ASTM E119 is our benchmark. ISO 6944 and ASTM E2816 get us there. They are the same fire exposure with the added pressure of the fan, which we want. That's a good thing. It's important to know that the additional dynamic stress of the fan is going to be accommodated by the test result. So those are good things, but we need to start paying attention now to whether we've done things like test both sides and use the lower of the two. So we need to see the listed product for ISO 694 includes duct B for the hourly rating we want. We need to see ASTM E2816 has conditions C and D for the vertical and horizontal tested specimens for fire inside, fire outside, as is minimally required. And we need to recognize that ASTM E2336 for grease duct zero clearance is not the same. It's a totally different test standard. It only has a half-hour fire exposure on the inside. These other tests, remember, we're talking about 2-hour fire-rated assemblies. That means the fire was inside for 2 hours. It was outside for 2 hours. So something that was only tested with the fire on the inside for a half hour for the grease duct test is not even close to the fire density that we need to be validating for ventilation purposes. And yes, you will correctly see that most of these fire-rated grease ducts have a companion ASTM E119 design. Okay, so you'll often see, if you get the listing card for the grease duct, it'll say ASTM 2336, and right underneath it's going to say ASTM E119 2 hours. That was an engulfment test. Okay, that companion listing means that it was engulfed to validate that it can go. What do we know we can't do with grease duct? We can't put dampers inside, right? So we need to penetrate and go into shaft assemblies. We need to be able to penetrate that 2-hour shaft assembly without a fire damper. And that's the only thing that companion E119 listing did. It was not tested as a shaft. Okay. It was not tested 2 hours, fire inside, fire outside, slab to slab, wall to wall. That's what we would need to substitute for a shaft wall that went slab to slab, or expect the same kind of continuity support and fire exposure symmetry performance that is expected from E119 for shaft construction. So grease duct systems are not tested the same, and the E119 damper omission application for engulfment under the grease duct testing is not the same. So we cannot use those any more than we can use the components. And this is the other problem in the industry. We very, very often see people treating the components and the assemblies as interchangeable. That very, very first picture that we saw, where we were looking at the stair pressurization, how to do it wrong in every possible way, we noticed that there was an access panel next to and required for service and maintenance of the sampling tube for that duct smoke detector. That access panel was a grease duct off-the-shelf access panel. It was tested at a 500-degree soak and a half-hour internal fire exposure if it's only listed for grease duct. Okay, that's not okay. That's equivalent to following that duct down to the end of the line where it meets the stair and finding a 20-minute fire door, where we should be finding a 1.5-hour B-labeled fire door to get in and out of that stair shaft. That opening protective would never be substituted for a 20-minute corridor fire door instead of that type B fire door. Why would we allow the equivalent of that? Why would we put in a grease duct access panel into that fire-rated duct that is supposed to be equivalent to ASTM E119 shaft construction? Don't do it. They're not the same. Every manufacturer of a fire-rated ventilation design has very specific access panel designs that go with that, and they don't look anything like grease duct. Okay, they're not interchangeable. Nothing about the systems, the support, or the configurations of the duct themselves are equivalent. The E119 approval for ASTM 2336 does not extend to the ventilation configurations from the same product line. Each configuration is allowed to be used for what it was tested for. The grease duct configuration for grease duct applications, type 1 commercial kitchen exhaust. The ventilation designs for ventilation and ASTM E119 we did on welded 16-gauge black steel or 18-gauge stainless steel does not translate to lightweight SMACNA construction or even the robust construction of the ventilation designs for the same product manufacturer, right? So the fire inside, fire outside is duct B for ISO, condition C and D for ASTM 2336. You need to check it on the listing card because they don't always test both configurations any more than the orientation always done. So again, you're going to find designs out there where they only tested it vertically. They're trying to use it horizontally. You need to go through the drawings and make sure that if they don't have a horizontal configuration approved for duct B 2 hours, that every single horizontal application on the job is done with something else that actually is. You're going to be told in many cases that the temperature control that's being provided by the duct A test somehow means that they don't need to do the fire inside test that's required for duct B. These things have nothing to do with themselves. Temperature control is an insulation value, and let me tell you, if you didn't do the duct B fire test for the fire exposure inside, you have no temperature control for that second fire exposure, and temperature control from the other side isn't even required in horizontal applications. We're going to talk about that in detail. make sure your duct size limit is checked. Most of these designs are often limited, sometimes relatively small duct sizes. So we're going to see 4.25 square feet as a limit on a particular design. Can they go to 13 square feet, 13 and a half square feet? And the answer is, if they have a design to go bigger, then they can go bigger. But they can't, it won't look anything like the smaller size. So the smaller cross-sectional area may have TDC, TDF flanges. And we're going to find that when they go to 13 square feet to get the same 2-hour duct B, that it took stitch welded companion flanges and two gauge thicknesses sheet metal. So thicker, more robust construction, more sturdy flanging, and of course all of that adds weight, so the hanging system followed. You're going to see that all of these things matter, and we only find them on the listing cards. So we're also going to pay attention to the fact that the support is going to be nothing like minimum SMACNA, right? The rod size is going to start at 3/8 inch. The trapeze bearer is going to start at small angle iron, and it's going to get the bigger angle iron, and then eventually it's going to go up to and include channels that get deeper and deeper and deeper in their section modulus to support that weight. There's no such thing as 10-foot, 8-foot even spans in fire duct land. You're not going to find strap in fire duct land or gripple wire. It's going to be these heavy trapeze bearers, 59 inches at most for small ducts which don't weigh a lot, and it's going to go all the way up to shorter spans, maybe even 48 inches for larger duct sizes. So we can't rely upon the conventional duct inspection to validate fire rated duct installations. And unfortunately, from one design to another for different manufacturers and different duct configurations, all of these things change. So there's nothing interchangeable from one manufacturer or one configuration within that manufacturer's product line from one to the next. So you have to have the listing card for the configuration that is being used on this duct run to know whether they got it right. We need to pay that much attention. It's kind of like the fire suppression, where we are looking at the fire sprinkler systems and the standpipe systems being supported by all thread rod with clevis clamps and cracked concrete anchors. That's not what it takes to hold up a 1-inch pipe full of water, right? That's what it takes to hold that up at 2,000 degrees when the residual strength is less than 10% of its normal tensile strength. And the same goes for the fire ducts. They need to be up for this entire fire exposure. It's bare steel that's hanging and supporting the duct system. So we're doing the same residual strength calculations when we're designing these duct support systems. If we're not following those more robust hanging system requirements, it's not going to be up there any more than the cold water supply, or hot water supply piping is going to be up there next to the sprinkler standpipe system 2 hours into a fire, right? So we need to pay attention to all of these little things, just like we do for other life safety systems, because it all matters, and it's much more complicated than the indoor air quality, ventilation, and conditioned air inspections that we're doing. It takes a lot more effort and a lot more detailed understanding of what the design requires in order to get to a proper life safety inspection. Let's get into some actual real world examples now. We've learned a lot in terms of fundamentals. We've learned how to translate those fundamentals into the test standards and the jargon, and we know where to look on the listing cards now to see what we have to do. But we're going to see some stuff on the drawings that are outright unicorns. And what I mean is, once you know the designs that are out there from the different manufacturers and how they're bounded, what their thresholds are, you're often going to see where the designer has literally put onto the drawing something that doesn't even exist. And you know it from the get-go because you know that there's no such thing, right? Here's an example, the 2-hour fire rated enclosure. I'm not talking about the typo. I'm talking about the fact that this is going to be interpreted universally by the contracting world as a drywall box around a duct. And what's the problem? We see a stairwell pressurization and 2 elevator shaft pressurization ducts, all starting out at a common intake louver. And we know that we need minimally for any drywall design, if the duct sizes are small enough, a 2-hour wall supporting that duct run. And we have one that's supposed to be dedicated according to the code, to the stair pressurization shaft. That system, that fan system, is supposed to be dedicated to the shaft. So we can't join the fans. We see that they did that correctly. There's an independent fan per shaft. But the other thing we're not allowed to do is conjoin the fire resistance compartment of those, right? We're not allowed to build scissor stairs anymore, are we? That's when we used to have one shaft enclosure around two different stair entrances, and they crisscrossed each other. Never known to the user, but he was dealing with one compartment protecting two different exit passageways, right? Two different exit pathways. And that's just not done anymore, because what happens is, if there's a compromise of the compartment, we lose two exit paths, not just one exit path. And everything in the current code system is designed so that we don't lose any more than one life safety system at a time for a single adverse event. That means I can't have one drywall box around all of these ducts in this room. I couldn't even accept a 2-hour room, a 2-hour fire rated room around all of these, and omit the fire rated duct for the intake louver through the room, because they can't be exposed to anything else in that room. Any other utility, any other thing in that room is exactly the kind of stuff we're supposed to be protecting these life safety systems from. And even each other, even unto each other. We don't want a problem with the stair pressurization equipment causing the failure of both of the elevator shaft pressurization systems. So each one gets individual dedicated protection, and that means from the intake louver all the way to the shaft connection. And in this case, there's no such thing as 3 walls that I can put next to each one of these duct runs across the corridor or even through the room and have compliant access to achieve that minimally necessary continuity support. Remember, it takes that 2-hour wall under each one and an L-shaped box. It's literally impossible to build that. It's not what they showed. What they showed could be accomplished with fire-rated duct if properly configured. So we have a design where everybody's going to provide 2-hour drywall boxes. Who knows what the heck we're going to get when we get out there to inspect it, because there's literally no evidence that they have planned in the continuity support that's required in the way of the walls. What are we going to get in the way of dedicated enclosures? Same thing happens when we see these kinds of crisscrossing designs. Remember, it's not just that we're going to slap up some drywall framing here and put some 1 or 2 layers of drywall around it. These need to be conforming designs. That means a shaft liner, a stud, and multiple layers of drywall, more in the horizontal. So when these things are going underneath of each other, that means I've got about a foot. If you were good at math and that you recognize that that was a 6-inch CH stud, 1-inch shaft liner, and 3 layers of 5/8-inch drywall, give yourself a little bit of room for hanging the duct above that, and you've got about a 10 to 12-inch deep horizontal assembly between one duct and the ducts that are crossing under it, and then those ducts get their own underneath of it, and then the two that are running parallel need something in between them to separate each one from each other. It's literally impossible to build drywall assemblies around this kind of mishmash of duct routing. So we can't use drywall to solve these problems. And when we have designs that say that they're going to do that, we've dropped the ball all the way up at the front of the game, because we've given the construction team and the inspection teams one hell of a task to figure it out after the fact and make up for that oversight at plans review. Even then, if you look at the right, you notice there in the corner, we see the VFDs that serve all 4 of these connections. Those VFDs, when the code section says fan, ductwork, power, and controls, the VFD is part of the power and control for these fan systems. It requires, again, dedicated 2-hour protection. So we can't have those sitting out in open air in the room 12 feet away, can we? Because anything that happens in that room is going to knock out the ability of the fan to run. So now we've spent a whole lot of time making sure we have good, proper 2-hour fire-rated ductwork, good, proper 2-hour fire-rated fans, and it's all going to stop as soon as the electronic VFD gets to about 100 and 12 degrees or something like that, the electronics go kaput, and we've got a system that doesn't run. We got to keep our eye on the whole system, and we need to capture protection for the whole system. Here's another unicorn. Here we see an 82-inch by 48-inch deep duct. We know even if we did see a wall running along this duct path for continuity drywall support, as note 7 tells us, that our span at 82 inches exceeds the 50-inch usable duct width, and we know that the 48-inch deep is the limit for the drywall assembly. Take out that 10 to 12-inch bottom panel, and we know that the usable duct size or duct depth is about 36 inches. So we have something that would require 2 walls running along this duct path to support a horizontal drywall assembly. So once again, a note describes drywall protection that simply cannot be possibly built in accordance with any known drywall assembly design limitations. How real is the problem? When I say the problem is real, this is what I'm talking about. There's a very, very large duct down in the bowels of a very, very tall building. That column is several feet thick. If you look at the background, there's that 16-inch wide, 8-inch tall, deep block construction for that wall. So this is a very large column, very, very large ductwork. Once again, we see that had this event gone for much longer than it did, the duct had already been compromised. Minutes into the fire, this duct had already been compromised. We already saw delamination at the collar. Why? Because the duct width demanded pinning and banding. Not only that, they used the collar method for the seam, which should have been a band over each loose end. They only put one band. It held on to one seam, but it didn't hold the other side, so the other seam came loose. Once again, we see that the bears are wrapped, so we would have had premature failure of the bearer. We see one bear on a duct that is several feet wide, and in the entire photograph, we see one bear. I assure you that the calculations for the bear, for duct that size, we should see several bears within the photograph that encompasses a fitting and a turn and 2 different run lengths that are well past 4 feet. So we don't have proper continuity support. We had improper wrapping of the continuity of the bear. We have improper seaming. We have no pinning to hold it in place. And the concomitant result was that not did it fail at 2 hours, but it failed at minutes into a fire exposure that in this case, the fire department was literally across the street, and they were on site in under 5 minutes, and the fire was out within 7 minutes. Had it gone on for longer than 7 minutes, we could very reasonably expect catastrophic failure of this duct system that was already failing. This is serious. These are supposed to be life safety ducts that last for 2-hour fire exposures. The fire department is not always right across the street, and the circumstances are not always necessarily that providential. Every single joint matters when it comes to these systems. I don't see the bolted flanges either, do I? The only change in the dimension of the outer skin is for the collars. So where I don't see bolted flanges, I don't have proper rigidity and strength. If I peeled this onion back further, I probably would find that the seams were not locking seams, and that the reinforcement was far less than required for ducts of this size. This was the mere appearance of fire resistance that did not manifest any harm to the building in and of itself, only through the sheer providence of the circumstances. We can't rely upon that. We need to make sure the systems are designed and perform in accordance with the code. The hanging system matters. The joining system matters. The duct fabrication matters. We also see that there was only one layer. Again, this one layer design does not exist in any conforming path in our code system. We see that the rod was only 3/8 inch for the duct that size. It should have been minimum 1/2 inch diameter rod. Again, this is a case study in just about everything that they could have done wrong. It was not a fire rated duct system. It was the mere appearance of one. Further down the line, we found actuators, duct smoke detectors, sensors, where they penetrated and removed the fire-rated material. The assembly has been compromised. Anytime we penetrate a fire-rated assembly, we have to provide a fire stop and or a cover. So I should never be able to see these things from the floor because they're all supposed to be behind a fire-rated access panel, accessible as required by code, but protecting the fire-rated penetrations that they impose upon the fire-rated assembly. We violated not just the F rating, we violated the T rating. We have violated the fire resistance. It's kind of like walking down the corridor and seeing a fire extinguisher that just happens to be along the corridor wall that is the same joining the wall of the stairwell. So they upgraded that wall to a 2-hour rating as it came down the corridor. The corridor maybe needed only to be 30 or a minute or an hour, maybe 30 minutes or an hour, depending on the occupancy type. But when the corridor wall becomes the stair wall for that length, it becomes a 2-hour wall for the stair enclosure. And yeah, there's going to be things that penetrate that wall. But when they do, we treat them as the membrane penetrations that they are, the through penetrations if they're allowed. And we would never say, well, gee, I need a fire extinguisher here, and allow them to just cut into the fire resistance rating and not address the fact that they've compromised the fire rated wall. They would have to use a design where the fire rating and integrity of that recessed cabinet maintain the fire resistance of the stair wall. In this case, it's the same thing. When we start punching holes in and removing the insulation material to provide accessories onto the duct, the accessories are required. That does not justify violating the fire resistance of the assembly. We need to take the appropriate protective cover for when that happens. Fire stops matter. There are companion fire stops for every single fire-rated duct system out there. There's no such thing as a fire-rated duct system where the duct gets tested and hasn't also been tested with a number of different fire stop designs for floor penetrations, different kinds of floor penetrations, wall penetrations, different kind of wall penetrations, different hourly ratings. And in all of those cases, you need to be very, very cognizant that the fire stop matters as much as the duct, and that not all of them are suitably appropriate to support the duct. What do I mean? In this photograph, we see that the duct has a support right next to the wall. Very often, you'll see that they put a support angle and they bolt it to the wall to support the duct piece that is going through the wall. And that is okay only if the wall is equal or greater than the duct rating. So that would have to be a 2-hour wall if they used the wall to support that piece going through the wall. So if it's less than 2-hour wall construction, then we can't take the angle that's built into the fire stop design and use it to support that duct piece. We need to independently support that duct piece as shown. So this one was done correctly in terms of the independent support. Unfortunately, the fire stop, that's not any known fire stop for any fire rated duct system. So they had to correct that fire stop. I also noticed that they blocked the access panel on the right. That needed to be corrected. And you'll see that where they came through underneath, they made all of the same mistakes and got the same parts of it correct. So at least they were consistent. So make sure that we're paying attention to whether the wall is appropriate to be used as a support. If not, the fire rated duct pieces going through the wall must be independently supported. And the fire stops are out there. Everybody's done it. If they haven't done it, then they're not ready for prime time. I'm aware of only one manufacturer in the US market who's currently trying to sell a European-based duct A, duct B type product where they have not done their companion fire stops. I'm here to tell you that if they haven't done the US-based UL 814 fire stop testing, that the European testing does not include hose stream testing, and so they have not fully tested those products for use in the US market. I think they're only operating on select areas of the East Coast, so I don't think you need to worry about it in your geography yet. Here's some more unicorns. So we see a note here, lower right-hand corner, we see a note and a leader that says 3-hour fire wrap. Okay, so unfortunately in that product class, there is nobody that has a hourly rating higher than 2 hours for duct B configurations in that product class. So there are fire rated duct systems that can get to 3-hour duct B, but all of the insulation products cap out at 2 hours. They have 3-hour duct A. Can they use 3-hour duct A for this smoke evacuation? Absolutely not. So that is a unicorn. What I mean by that is the designer has specified a very, very specific fire rated duct solution. It would have been okay if they said 3-hour fire rated duct B. They would have left the field open for any number of manufacturers, but they said something that, again, in the contracting world, this means a very specific product class, and that product class literally has nothing that gets to that hourly rating in a conforming symmetry tested configuration. That's going to be an omission that slips all the way through, gets caught late, if at all, or as a change order waiting to happen. We see some smaller duct work up at the top there that's identified for 2-hour fire rating, and those can be done as specified and designed in this case. Here's another design. This is some pretty big duct work. If you look at those intake louvers, they're monstrous. You could drive a bus through that. The duct work leading into the fan discharge, 52-inch diameter. The duct coming in, 72 by 24 on the intake side. These are some really big ducts. I'm telling you, it's really hard to go big with fire-rated products in general. And unfortunately, when they say, again, we see here in the center note, 2-hour fire wrap, we wind up in a situation where they've been very, very specific in the product class within the fire-rated duct industry that they want applied. And we know that only 4.25 square feet, I'm sorry, 4.25 square feet. That's it. The only product class design for the insulation part of the fire-rated duct industry caps out at 4.25 square feet. So that means every single duct size denoted on this drawing exceeds the maximum allowable size for that design, which means they've, again, designed something that doesn't exist. There are 2-hour fire wrap duct B designs, but none of them can go this big. Here's another example. We see that the blue duct, lower left-hand corner, is identified 24 by 16. That is actually less than 4.25 square feet. So when they say that they want 2-hour fire wrap for that duct run, that is a product configuration that exists. Unfortunately, the purple duct that we see up at the top of the drawing says 3-hour fire wrap. So once again, we run afoul of the fact that that does not exist. 3-hour duct B does not exist. I want to make a general note here. It's not related to the fire rated duct, but it's really, really, really important. 717.2.1 of the code is very, very clear that we are to omit fire rated dampers, right? And fire rated duct systems, dedicated fire rated duct systems, when they would interfere with the smoke control system. So they have just got these fire dampers all over the place on this drawing, in smoke control systems that are going to run afoul of that. You know, that is not an optional paragraph, right? It mandates the elimination of fire dampers that will interfere, because the interior fire exposures of any one of these duct systems and any one of the bounding rooms here would cause that damper to close and render all of this fire rated duct moot, because they would not be able to function. So they're supposed to be following that paragraph to the T, which says eliminate the fire dampers that are supposed to be otherwise required, use alternative protection. That's what the fire rated duct system is. All of the ESRs out there tell us if we eliminate a fire damper and we use duct B, we have provided that alternative protection. So the whole point of the code requirement to use fire resistance protection for these ducts is so that we eliminate these fire dampers that are going to render the system non-functional. This is more is not better. Okay, this is not belts and suspenders. Okay, the fire damper with the fire rated duct is not doubling down on your protection. It is designing something that is in direct violation of 717.2.1, and it will render these systems non-functional because the damper does exactly what it was designed to do. We've got to pay attention to that. I see it way too much. Get rid of the fire dampers when we have fire rated duct systems. Where you have an FSD requirement, make sure that they don't use that combination dampers. when it's the fire rated duct system, it drop the fire part, use just the smoke damper. The smoke damper alone does everything we need it to do. The fire rated duct system takes care of the rest. And when we put those combination dampers in, a lot of people think that they can be overridden. There's actually a hard stop on that. There's an override built in at the damper. Everything that is about all the limitations of a fire damper at its threshold temperature will kick in and cannot be override. There's no override under any of these combination fire smoke dampers that can open that damper once the threshold fire temperature for the fire damper trigger activates. Just like any other fire damper, you need to go out there and reset it after the fire. And we have, by then, completely lost all of the functionality of our life safety HVAC system because we allowed something as simple as an FSD to slip through the cracks when it should have just been rendered as a smoke damper because it's in a fire rated duct system. So we need to do a lot of work understanding the jargon, keep an eye on the jargon, recognize there's two different test standards and the jargon's different. Condition B under ASTM 2816 is not the same as duct B in ISO 6944. In fact, it's the opposite. One is the duct we don't want to use. Condition A and condition B are the equivalent of duct A horizontal and duct A vertical under the ISO test standard. So we're looking for conditions C and D. There are some listing cards out there that are very, very tricky to catch that on because the condition A and condition B look just like a conforming listing card for ISO. So you got to ask for the listing card, and then you got to take care to look very, very closely at it and make sure that you recognize whether you're looking at an ASTM listing card or an ISO listing card, whether you're looking for condition C and D or duct B. Recognize that all of these test standards other than ASTM E119 technically are not the prescriptive test standard. And even though they have things we want, which is the pressurized duct that's been stressed under the fire exposure, we do need technically to dot our I's and cross our T's, which means we should be submitting either as an alternate method or as a code modification for the deviation from ASTM E119. And again, can't stress this enough. I don't care if there's an ASTM E119 approval for the grease duct. It does not extend, translate, or in any way affect other configurations that deviate from that configuration and that purpose. Okay? ASTM E119 applies to that configuration only and allows them to emit a damper when that grease duct goes through a fire barrier or a fire rated wall. That's it. It doesn't affect the ventilation designs whatsoever. So if the ventilation design is ISO or it's ASTM E2816, then technically they should be submitting an alternate method submission. And that means they need to make sure that they're providing equivalent fire resistance. You read the paragraph 104.11 in the code, it says it shall be equivalent, minimally equivalent in fire resistance. And so that means it needs to be tested both sides using the lower of the two results. That means they need to follow orientation, use the product orientation that was tested. If the configuration changes, the duct design changes for the horizontal versus the vertical orientation, that they need to use the right one for the orientation change. And when they have ISO 694 or ASTM 2886 instead of ASTM E119, what do they need to do? They need to provide an ESR that tells you exactly these things. So there's this document called AC 179 from the ICC ES department that tells you here's the acceptance criteria for these two test standards. And if you follow that ESR, that evaluation service report, they'll tell you that it can be considered equivalent to E119. And all of those ESR reports are going to tell you these things that I'm calling out. And if anyone offers to give you the ESR without giving you the listing cards, I'm going to show you what the ESR says. And the last thing I'm going to talk about is the opportunity that people might look at. They say, well, what about I'll just submit it as a code modification so I can use the dumbed down version of the duct. The language in 104.10 says you may modify or deviate from the code only if it is not practical to provide equivalent protection. And I don't understand why anybody would even conceive that if there are products out there that are equivalent, what is your justification that what is impractical about using the ones that are? Is it impractical because your insulation provider likes this brand over here instead of that brand, and they can't do it the correct way, so you want a code modification? I struggle to see what's impractical about using a product that is different than the one that your insulation provider typically uses, likes to use, has a good deal on when he buys it from the distributor. It just doesn't make, none of those things pass the litmus for a code modification. There's nothing impractical about using products that are readily available on the market, cost efficient, and provide equivalent fire resistance. It just doesn't make any sense. Last thing that is out there in terms of a myth that I like to point out is these people who will tell you that, well, duct A and duct B are the air service. Not that it has to do with the testing fire inside, fire outside for symmetry conformance from the code, but that duct A is supply air ducts and duct B is return air ducts, because duct A has openings and duct B, or duct A doesn't have openings and duct B does. And you can't think about it very long and agree with that, right? Because every duct system out there has an intake and an outlet. So that means there's openings somewhere in the building. And unless it's all in the same compartment, in which case there's no code path that tells you to make it fire rated in the first place. So if it needs to be fire rated, that means you're following some code path where you're traversing multiple compartments and serving a dedicated compartment. Then you have openings. And if you have openings in one compartment, then there is the fire scenario where the origin is in that compartment or the adjacent compartment. Again, all probable fire scenarios is our litmus for conformance under the building code, right? 909 says all probable fire scenarios. So that means we don't get to pick which one we think might be the most likely one. We do all of them. And when we do all the probable scenarios, the adjacent fire compartment is always going to end up having the opening either on one side or the other. And once you're duct B, you're always duct B. You don't get to switch. You can't switch the duct during the fire from duct A to duct B if the fire scenario is in the adjacent compartment with the opening, right? And there's no such thing in the code that says you get to skip fire resistance if it's a supply air duct. And we'll talk about the myths behind the idea that that's even relevant in the first place. Right? So equivalent means you need to vet that the design has an ESR. The ESR is being followed. It's going to tell you if you're omitting dampers, replacing shafts, that you need to be duct B. If there's calculations or tabulations involved with going bigger than the the listed approved design, you need to see those calculations and tabulations. I have seen some real nonsense here. I've seen people use the smallest possible duct design, and remember that one where they could drive a bus through the intake louver? They wanted to use a design for 4.25 square feet to build that duct. And let me tell you something, when you go big enough like that, you're going to be using casement construction, and it's going to be big, heavy. It's going to make smacking on steroids really doesn't get you to the place where you need to be fire rated when you go that big. So there's going to have to be multiple data points, multiple designs, and some calculations involved through extended applications testing. And I'm here to tell you, everybody in the fire rated duct industry has that data. So if they're trying to give you one design for a real small duct and tell you they want to go as big as they please, and they find somebody who's willing to write a letter that says that that's okay, you're dealing with people who are not familiar with the limitations of their products, not familiar with the fire science involved. Full stop. Start asking these questions. It's going to take heavier gauge construction. It's going to take, once you get above 98 inches, everybody should be using some kind of casement panelized construction. That's just what it takes to get the fire rated duct land. The steel underneath exists for all of these designs, and the steel is the same it performs the same for all fire rated duct systems. The properties of that steel does not change as it gets hot. Again, the variance or modification path, it's a conceptual path, but there's nothing impractical about meeting equivalent fire resistance when there's plenty of product designs from many different manufacturers that are capable of providing equivalent solutions for the project. If you get evaluation service reports and they don't want to give you the actual listed designs, trust me, the report says I can use this product any way I please on the job. That's not what the evaluation service reports say. What they say is you can consider this test standard for the fire rated duct equivalent to ASTM E119 if the fire rated duct is applied this way. And then it's pages and pages and pages of requirements that they need to follow, all of which tell you test both sides, use the lower of the two if you're omitting a damper. All of them tell you do the same thing if you're replacing a shaft. And so it's really, really confusing when they give you, an ESR without the actual listed configurations they intend to apply, when the evaluation report tells them to attach exactly that to the ESR for you to review and confirm that the configurations being proposed conform with the ESR itself. So don't settle for an AMMR or an alternate method report under 104.11 if it attempts to deviate from the code. It's not allowed by the alternate method approach. It must be minimally equivalent to be an alternate method submission under 104.11. Only the building official has the power to approve that, okay? I don't know why I need to say that, but you're gonna find we're gonna talk about that when we get to smoke control, where a lot of people try to do that under false pretenses as part of their special inspection activities. I assure you, we're gonna read the exact language. The special inspector does not have the power to deviate from the minimum fire resistance required by the code. And so when you follow the alternate design, the alternate method, you need to provide minimally equivalence, the minimal equivalent fire resistance, and the building official must be convinced. And that means submitting the evaluation report to the authority having jurisdiction. And that could be a UL evaluation report. It could be an ICC evaluation report. It could be an ICBO evaluation report if it's still been kept up to date. There's IAPMO evaluation report. There's lots of trusted agencies or approved agencies, as the code calls them, that are allowed to issue those evaluation reports, but it needs to have the UL, in this case, the UL design needs to be attached, okay? So if they're not providing the applicable published UL design that goes with the ESR, you should start asking questions. Is why someone would suggest that you don't need to see the configuration that goes with the project applications, that the ESR allows them to do whatever they want. That's not what it says. It says attach the configurations you want to use, and where you're substituting them for fire dampers, you need to follow 3.6, which says duct B. And where you're substituting them for shafts, you need to follow duct B, okay? And so when they specify which design, in this case, it's HNLJ V-36, you should see that attached, because that design looks very different than some of this product manufacturer's other fire rated duct designs. None of those are covered by the scope of this ESR, right? Just like the ASTM E119 approval for the grease duct doesn't translate to any of the ventilation duct designs. If the ESR covers HNLJ V-36, none of their other fire rated duct configurations conform with that evaluation service report. That means they don't meet AC 179, and that means they are not to be considered equivalent just because they have a test to ISO 6944 or ASTM E2816. So in this case, we saw them try to backdoor condition A and B by adding it into the summary analysis on the cover sheet. Do you see what happened here? They took an ESR that said it attached the configuration. They attached configurations for both condition A and B and C and D. And even though the applications on the job were all shaft replacement or damper omission, because they always are, right, for fire rated duct designs. So then, even though they did that, they still tried to include their inferior duct in the summary of the cover sheet, hoping that nobody would actually read the report or recognize that it meet the conditions from paragraph 3.6 and 3.5 from AC 179. So you got to be careful when you read these things, because it can all look very official. It can all have laboratory labels on the reports. It can include listing cards, and it can include listing cards for those that do and those that don't conform with the report necessarily, if they attach any at all. And if you approve that, it's going to be a fight later on about whether you were approving the inferior configurations, even though they're not discussed in the ESR. So very, very careful to do your due diligence, because when this diagram is embedded in the submittal somewhere, and it does not conform with the ESR for the damper omission or the shaft replacement applications on the project, you're still going to have somebody on the project team look at this design and say, that's what I'm doing. And it's going to be a fight with the inspectors at the end as to why they did not use the one that was conforming, right? That is in the ESR for damper omission 3.6 of AC 179 or shaft replacement paragraph 3.5 of AC 179. Note that they include the cautionary statement about fire stop penetrations. You must follow the fire stop penetrations that go with them. The fire stop penetrations, those designs and the duct designs themselves both have size limitations. So those need to be coordinated, not just for the penetrated assembly, but also to match the duct sizes on the project. And you will probably, in all likelihood, for large duct designs, need an evaluation or an engineering judgment for the fire stop to go big. Again, the fire stop gets harder the bigger you go, just like the duct gets harder the bigger you go. Notice the minimum qualities of this fire rated duct system for this project. 22 gauge construction. That's not going to be minimum 2-inch pressure class duct construction, right? 14 square feet. Looks like a lot until we realize that this was the non-conforming duct A. When we looked at the duct B, it turns out that it was only 4.25 square feet. Note that it needs bolted flanges. Note that it needs transverse joint reinforcement. All of these things, the rigid trapeze supports, this rigid support, they're talking about trapeze supports. That's not gripple wire and strap. All of these things are baked in, and you don't know the limitations on them until you actually have this detail that's only found in the listing card. That's why you need to ask for the listing card. Here's the actual duct conforming duct B configuration. Note that it's 20 gauge instead of 22, right? So we just got thicker steel, and the size limitation dropped drastically from 14.17 square feet down to only 4.25 square feet. And we can see that their duct B design, they do actually have a duct B design. They told everybody on this job that there was no design for their duct B ventilation air duct that could go bigger than 4.25 square feet. And that was their justification for using that very, very minimum lightweight design for really, really large duct. And trust me, it'll be okay and it'll work. When in fact, if the consultant who looked at it had looked at the Intertech fire resistance directory online and punched in that manufacturer's name, he would have very quickly found that they do have a duct B design that goes up to the size of 13.5 square feet. Still not quite big enough, but a second point to do the extrapolation calculations. Unfortunately, if you look at the fabrication, it's extremely different. They went to those cross-stitched companion flanges, really, really heavy gauge sheet metal construction, lots of reinforcement specified, none of which bears any resemblance to that 4.25 square foot design. So when it says that there's an upper limit on the area of the duct, it matters. And if you want to go bigger than that, you're going to need to do some more analysis. This is where I'm going to ask some more questions, and we'll take a quick break. Hopefully these are easy. Condition B is the same as duct type B. Is duct A always good for outside air because it's supply air? Fire rated ducts are a substitute or an alternate method for built assemblies under Chapter 7. Is that always true? Or can we apply code modifications or variances to fire rated ducts under 104.10? All true, false. Here we're going to see our answers. I'll let you review the answers, and then we'll take our break.